Hey, good afternoon. I am going to just recap real quick for you week one of statistics, but also kind of dive into what are we doing in week two. And you'll see this on the syllabus for week two. But I wanted to be able to kind of verbally talk through some of the things. So in statistics, week two coming up here, you'll see, first of all, I mean, it is a crazy week one. We only really got 2 days of actually kind of really getting content in there. And it felt really crammed in to get those 2 days in. I think that's a good thing looking at where we are now, but also it helps me to kind of figure out how I want to set up chapter 2 and kind of help out with getting the information a little better. So stay tuned for that. I'm going to kind of work on the timing and things like that. So here's what we got going week two. Today is Monday. Monday is another day off. Really just, this is really a community-based day to say that, hey, we understand that the air quality is not good. So we don't need to stress about both school and air quality. And we do know some of our own staff had to evacuate their houses. We're hoping they're able to get back into their houses. And then we also know that, a lot of people have family around all these areas that are affected. So again, we want to be able to spend time with family and get our lives kind of back together. So the district has, I think, done the right thing, which is just give a couple days off to just say, like, let's work on community and family. So here we are Monday, a day off, but I'm taking some time to kind of set up this week for us during this. First, for tomorrow, Tuesday, be sure that you have seen the 1.3 videos, and really that's going to be talking about box plots, how to actually determine IQR, right, the interquartile range, and then how to determine an outlier using that IQR, right? So we call it the 1.5 times IQR rule. It's kind of a, it is what it sounds like, right? It's you take 1.5 times IQR, and then that is the rule that helps you find outliers. So those are really what you're working on. And then just kind of thinking through stem plot, dot plot, histograms, what do those look like? And then pie charts and bar graphs, right? Really just trying to, all this way to organize data. So week two, Tuesday, when you come in, we want to kind of recap some of that stuff. What is a box plot? How to find those outliers? And then kind of do some work, and we'll kind of set it up a lot like we did last week, which is we'll do some work together, either using some data or just kind of working on problems. And then we'll break in some smaller breakout groups, and then have you guys just kind of, work together and try to figure this thing out, right? So that's what that will look like on Tuesday. As we get into Wednesday, we actually want to review some of this stuff that we're doing. So want to kind of just like, hey, here's some problems, review it. During a review day, know that you'll do some things that'll start the assessment process. So the assessment process being quizzes or data sets that make you guys kind of work on those things together and produce something back for me. So we'll talk a little bit about that as we get into Wednesday. Sorry, not Wednesday. Let me just, so that's Wednesday. So then Thursday, I will have you kind of actually do an assessment. And so we're going to do our main assessment through AP Classroom. And that's a website. It's on the College Board website. It's actually where you go to register for the AP exams. But since we have access to it here, even though we're dual credit, we also have PCC credit available to us. But we want AP Classroom. So what you can do is AP Classroom. If you haven't been there yet, go to the AP Classroom. You can even Google it, AP Classroom, if you need to do College Board. And basically what you need to do is kind of sign up and get an account. Now, if you've done AP in the past for any of your classes, then you'll have this AP Classroom already kind of set up. So then you can sign in, and then you'll put in a class code. Now, in your Google Classroom, go to that under the administration link. There is a document in there that has your AP Classroom code in it. Put that AP Classroom code, it will get you assigned to the right period for statistics, which is what you want to be in. And it should actually, I think it actually will say your period. It'll say quarter one, period two, quarter one, period three, quarter one, period four, whichever one you are. So go ahead and get signed up for that, because we will use AP Classroom for that test day, which is on Thursday, the assessment day. And then you'll see something that I'm working in to these, since we have 9 weeks in this quarter, but we're just really pounding through a lot of information. I want to have time that can kind of really serve more like a college and have some office hours where you can kind of ask questions on your own that you've had kind of developing, um, and or just work through a problem or two if you need that. So that's going to happen on Friday this week. Now, I'll try to get it. I'm going to try to make it so that it's probably going to be middle of the week most weeks, unless we have an assessment kind of right in the middle of the week. So then it'll kind of bump a little bit. But one day, which I'm going to call a work day Wednesday, work day Friday happens to be this week, where I'm going to kind of pre-do some of the assignments and then just put them on Google Classroom. And so your job will just be to actually go through, watch some kind of video and just do some problems that whole time. Now, if you have come by Friday and you're like, okay, now I got some questions. So I will have my normal Zoom link on, and then you'll go into the waiting room if you get on there, and then I'll just pluck you out of the waiting room one at a time, ask questions, and then do that. Or if I pluck you out and you're like, hey, both me and Steve, who's also in this period, have a question, then I can plug both of you out, and then we can just kind of work through problems together on that, in that sense. So that's kind of what a work day. So you'll see I put that on the syllabus. It's a work day Friday, and that's introducing the new chapter. And there'll be a video that'll go along after your test day, just like normal, because we're doing a flip classroom where you take your notes and you do some of that. And then on Friday, there'll be some prescribed stuff that you go through. And as long as you do the Khan Academy during the period or log on and do a little office hour with myself, then that's how I'll do attendance for the day for that. So that's kind of what it'll look like. That is this week, right? We're just trying to recap chapter 1, which is making some graphs, organized data, talking about socks. And then we're moving into chapter 2, right? But remember, we got 9 weeks. We're trying to really kind of crush it to chapter 7 here. We'll see if we get there, based on how things are moving right now. But that's okay. I'm not too worried about content as much as, I want to make sure that we're feeling good and comfortable, and we're kind of getting into a groove in this whole statistics thing. So there you go. There's your that's what we're doing in week 2. I'm going to do a real quick recap. So if you don't feel like you need a recap, you can stop the video here. If you do want just a quick recap, just hang into this video here and we'll recap it. Okay. All right, we'll see you guys Tuesday morning and or afternoon, depending on which class you're in. All right, so let's talk real quick recap. So 1.1 was really just about trying to identify variables. What are the different variables from what individuals, and then how do we organize it? So really we talked about if I took a data set and put it all into categorical data, what we do is build a frequency table. Right, and so that would be, let's just say, since it's an election year, let's say that I went to a group and I wanted to find out who are you voting for? Not really so much who as far as like the party, right? So I would say my party would be over here, and then we'd do like Republicans, we'd do Democrats, and then maybe I just want to give the other is just other, right? And so I don't really care what that other one is, right? It could be any of the other multitude of different parties that like to emerge during these things, right? And unfortunately, in our country, is those other parties don't really stand a chance against the two main parties, Republican, Democrats. But that's party, and then we would do frequency. Now, frequency is just a fancy way of saying counts. So as I take a data set, let's say I'm looking at 100 people, and I'm even going to do n equals 100. Anytime you see a little n, the little n means that that is how many people you were talking about, sampling. If I went into a forest and I said n equals 100, that means I'm going to look at 100 trees, whatever it is, right? So the frequency, 100. Let's say I got in this party, let's say we had 42 Republicans, we had 45 Democrats, right? So then we had 13 people say, I'm going to do other. So what should happen is your frequencies should add up to 100, right? Because that is your sample size. So it's called a frequency table. Pretty basic, pretty plain. And then from there, we really talked about just building a bar graph. And a bar graph, literally, you just put the different categories, no matter what they are, of your variable, right? And then we would say down here, we'll call that party, that's labeling. And then on the left-hand side, we would have some kind of scale. Now, if we're doing it out of a general scale, right, we might do this thing 10, 20, 30, 40, 50, right? And then you're just gonna put a bar above each of these. So I'm gonna go, Republican is 42. Again, this is just made up data, but just trying to give a basic idea what's happening here. Democrat would be 45, so slightly higher. Now notice what I'm doing, I'm not letting these bars touch because these are categories, and these categories, the bars themselves in the order that I put them don't matter, right? So what does matter is the height of each of these bars. So we would like them to be all the same width, and then the height is what matters because our eyes are drawn to area, and we're talking about the height difference so that we can kind of quickly see this thing, right? So that's kind of the way that would break down if that were the case. So that would be it. I should have frequency, right? Just want to label everything. So there's a bar graph. And then we could change this to a pie chart. That's what I'm going for. I can change this to a pie chart. Now, pie charts have to be percentage, and it has to be out of 100%. No more, no less. It has to be exactly 100%. So what you would do is you'd come over here and you'd build what we call a relative frequency graph. So relative frequency. So the word relative frequency literally means percent out of a whole. Relative to the whole, what is the frequency, right? So that's how we do it. Now, since I magically made 100 in my sample size, makes it easy. 42 out of 100 is 42%. 45 out of 100 is 45%. 13 out of 100 is 13%. Right, so that made that nice and easy. So as I go to build a pie chart, we're gonna pie this thing off. And if I was just gonna divide these in, right, so then I get like, that's not a great circle, and my lines aren't great and straight, but good enough. We'll get a pretty good estimation on kind of what's going on here. So what I would want to do is just kind of put this, so Republican Party, Democratic Party, and then I got my other. Right, a lot of times these things gotta get colored in with different colors, right? So they would look like this. All right, I color it in a little bit. Sometimes they even put the numbers on there. So we do 42%, Democrat would be 45%, other would be 13%, and then we would say something like party, like party affiliation, whatever it might be. So we talked a lot about that in 1.1. So up there, what you're seeing is a frequency graph. You're seeing a relative frequency graph. You're seeing a bar chart. You're seeing a pie chart, right? So all those came from that normal data set right there. So that was 1.1. As we got into 1.2, literally we really only did 2 days worth of work. The first day, last Tuesday, was kind of setting up and welcoming. Wednesday was 1.1, kind of that stuff, right? Kind of really working through some of those problems, talking about it. 1.2 was is all doing the same thing, but now we're talking about doing it with quantitative data, right? So then we built stem plots, stem and leaf, sometimes we call that, but stem plots, histograms, and dot plots. That's really what it was. So let's say we took some data and we just got some numbers, and I'm just going to throw some numbers together real quick, just to kind of make this thing happen. Let's say we had 1. I'm going to go ahead and put them in order from least to greatest. 1, 1, 2, 8, 8, 9, 11, 13, 20, 22, 23, 23, 25, and let's go ahead and do a 41. I don't know what these numbers stand for. I just made them up. But let's just say we're given this data set. For whatever reason, Let me just count how many numbers I put up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. All right, so again, just so that you know, I'm talking about a size of 15. Right, so that's what it is. That's what you're looking at. There's my size of 15. So a couple different things we talked about was like finding the mean of a data set. So we can definitely do that, find the mean, find the median of the data set, and then being able to build different graphs. So let's talk real quick about different graphs. So let's go dot plot. So dot plot, literally you take a line and you start putting values on here. So I'm going to go 0, 5, 10, 15, 20, 25. Huh. I even made this not good enough for myself. Keep it going. 30, 35. Okay, well, gotta love just making stuff up on the fly. It really slows things down, doesn't it? And then let's go 40. Okay, so dot plot, it's literally taking every value and putting a dot above its number. So we got 1, 1, 1, 2, and then it jumps to 8, 5, 6, 7, 8, 8, and we got 9, got 11, we got 13, we got 20, 22, 23, 23, 25, and then one at 41. Okay, so there's a dot plot, literally dots, and you're gonna just stack on top of repeated values. Like most things, we would label it with whatever the label was. Since this is an unlabeled data set, then I would just put those things on there. There is your basic dot plot. All right, looks something like that. Let's go stem plot. This is the next one we did. So stem plot, essentially you look at how many digits there are. And in this case, I see 2-digit numbers. So your stem is always going to be the tens place of the 2-digit numbers. So 0, then 1 being the tens, 2 being the 20s, 3 being the 30s, 4 being the 40s. Now here's the deal. So you look at your lowest number, so the zeros, right, that we have single digits, all the way up to the 40s. So you have to represent every value all the way up to the 40s, right? Even though the 30s, notice there are no 30s, that's okay, because we're going to leave that blank. And then within each of those stems, now we put the value that's going to attach to it. So 0, 1, and then there's a 0, 1, and there's a 0, 1. Now notice I'm not putting commas in there, I'm just putting spaces between them. Spaces represent the next value. Then there's 0, 2, there's 0, 8, 0, 8, 0, 9. Okay, so that's how that works. 0, 1, 0, 1, 0, 1. I'm going to build a key here in a second. But then I got 1. So 1, 1, that would represent 11. 1, 3, that would represent 13. Now I'm done. So now I'm going on to the 2s. 2, 0, 2, 2, that would represent 22. 2, 3, there's another 2, 3, 2, 5. All right, that's 25. So that would represent those 30s. Again, we said there are no 30s. Well, let's skip it. And then you go down to 41. So that's what that would look like. Then I would build a little key over here. And in my key, I just want to pick any of the numbers I see on there, just so that when you see those numbers, you know exactly what it is. Because a 2 and then the slash could represent a decimal point. So it could be 2/2. Right, let me use that. 2/2 could represent 2.2. It could represent 2,200,000. We don't know what it represents until we finally say 2/2 represents the value 22. Now, if it was money, I'd put $22, whatever it might be, right? So that would be what it is right there. That's called a stem plot. Right there. So you got the dot plot above, then you got the stem plot, and then we also built a thing called the histogram. Now what the histogram needs, it needs a new frequency table, because essentially we're going to take quantitative data like what you see up there, and we're going to force it into categories. Now the categories we get to force it into, that is our choice. We get to kind of choose that category. So this one, I'm going to kind of squeeze my categories down a little bit. So let's do this. I'm going to call this categories. And then this is going to be the frequency. So very much like it was with the bar chart, we're going to kind of do the same thing. So categories, I get to decide. Now in the Khan Academy videos, they call these buckets. And I like that because it's a good visualization. Like imagine you had a bucket and you put a label on it and you said 0 to 5, which is what I'm going to do. Actually, I'm going to do 0 to 4 because that's 5 digits. 0, 1, 2, 3, 4. Notice that's 5 different digits in the 0 to 5 category. So let's call my first bucket 0 to 4. My second bucket would be 5 to 9, right? Again, that's 5, 6, 7, 8, 9, right? So that's 5 units in that one. And then we're just gonna continue this on. Let me just do this real quick. 10 to 14, 15 to 19, 20 to 24, 25 to 29, 30 to 34, 35 to 39, 40 to 44. Okay, so that's what it looks like right there. And I know it's getting smaller and smaller and smaller as I do this. But now literally I'm gonna go back to my data set and I'm gonna count. I'm gonna count these values. So how many are in the 0 to 4 bucket? So imagine it's a bucket labeled 0 to 4, and then you're going into all these numbers and you're only gonna pick the ones that work in that. So 0 to 4, those are those 4 values. So the frequency is 4. 5 to 9, there are 3 values, right? Those are gonna be the next 3. Now the 10 to 14, it looks like we got 2 values. 15 to 19, no values. 20 to 24, we got 1, 2, 3, 4. 4 values. Then there's 1, 25, and then 25 to 29. And then there's 0, 0, 1. Okay, so that's building my frequency table for quantitative data. Now, check that compared to the frequency table. It's the same idea, only these are true categories here in 1.1. 1.2, these aren't actual categories that were given to us. I made these categories up. I made these numerical categories and then got to put stuff in it. So then that's what that looks like right there. So then histogram, let me finish building this histogram now. Now it looks a lot like a box plot, only it's not. It's actually a numerical. So where this thing would start, let's go 0, 5, 10, 15, 20, 25, just like I did earlier. I'm not good with this. 30, 35, 40, 45. Okay, that's what it looked like there. We would label this for whatever it was if we had an actual label for those numbers. And then we're literally just gonna put these charts up here, and I'm actually gonna see, it looks like 4 is my greatest. So we got 1, 2, 3, 4. And this is really called the frequencies, or the counts is another way to say it, right? So the first bar from 0 to 5, like in that range. So starting at 0 all the way up to 5, but we're not actually going to include 5 in this first bar because that's the first category. Oh boy, it just swapped on me. So then I'm going to put my bar. You can see, obviously, if I was doing this nicely, if I really needed to make a presentation, I'm putting this thing like with paper, pencil, and I'm using a ruler or straight edge, but not needing to worry about that. All right, let's look at the next category, 5 to 10. That's starting at 5, because the first bar didn't include 5. So this one's going to start at 5 and include anything up to 10, but don't actually include 10 in there. So that's going to be a 3. I'd color that in. Now notice the difference between this and bar graphs. Bar graphs, the bars don't touch because those categories aren't really associated with each other. So I could flip the bars around and it's not going to matter. On this one, since I'm going from 0 to 45, those numbers mean something. So the order matters. And since I'm going to go one category right into the next category, I want them to actually touch as if there's a merging between the categories, right? There's a reason they're right next to each other. And there's like an infinitely small gap in between them so that when you merge from one number to the next number, it makes sense to keep flowing. So that's kind of why we don't put gaps in histograms. 10 to 14 gap. That's the next one, really. 10 up to 15, don't include 15. That's going to be a 2. Okay. And then we got a 0. So literally just going to leave it blank. You don't even have to write that line in there. I'm just showing you there because I'm saying there's nothing there. And then it jumps back up to 4. Right, it'll look like that, 20 to 25, and then we're back down to 1. And then another 0, and then here's another single. And you got it. That's a histogram, right? Building a frequency table on that. So dot plots, the basic dot plots and stem plots, not good if you have a big set of data, right? Because that's every dot represents a new data point. And a stem plot, every number you see on the right side of the equal or the slash is a new data set. So you definitely don't want that either, right? So those are small data sets. If they get big, histograms are great for big data sets. You could give me 1,000, as long as they're buckets, I'm just throwing values into these different buckets. Hey, let's throw all the values in. And that's what it would look like, right? So histogram, dot plot, stem plot. I want you to have that down, right? That's what we kind of covered last time. And then all we're really gonna do, lastly, is describe the data. When we say describe the data, it means socks. So shape, outlier, center, spread. Now, outlier is something you're actually going to be doing on the video that you're supposed to get ready for on Tuesday, how to actually find outliers. But we'll kind of work through that real quick. So let's talk about S. That's shape. Shape, we said there's only 3 that you're going to use. It's either symmetrical in shape or it's skewed. And it's going to be either skewed right or skewed left. So on this one, since most of my data is right here, but then it trails off to the right, we're going to call this skew right. Okay, so that's what that's called, skew right. Now, if it was all lumped on the right side and looked like there was a little bit of trailing off to the left, it's called skewed left. If for the most part the mound was in the middle and it's skewed both directions, or there's just a mound in the middle, or it's 2 groups on the outside and a lull in the middle, it's called symmetric, right? Symmetric has kind of all different types of things. Think geometry, think symmetry in shapes, like a triangle is symmetric, a rectangle is symmetric, right? A circle is symmetric, right? As long as the right and the left kind of look the same, now it's stat, so it's not gonna look exactly the same most of the time. But anyway, you get the point. Symmetric or skewed right or skewed left. You're gonna use one of those. Let's talk outlier. Oh, it's outlier. Outlier is just like any data that looks like it's away from the group. So I'm gonna kind of call this here the group. That guy looks like it's outside of the group, right? So in this, that one right there, I'm just gonna say potential outlier, number 41. I think you might be a potential outlier. Now, what you're going to look at is the video, if you haven't gotten to it yet, for Tuesday, is how to actually calculate, is that an outlier or not, right? We call that the 1.5 times IQR rule. So look for that. All right, center. There's 2 centers we like to use. We like to use the mean and the median. So the mean is really adding up all the numbers and then dividing by the number of values we have there. So that's like 15. So if I added all these up and divided by 15, it would give me the mean. Now we actually use a symbol. This little X bar is the symbol. So you'll start seeing that. We'll talk more about that this week. But this X bar, the mean, we'd say the mean equals, and go ahead and give a number there. I don't know what the mean is, and I don't have my calculator readily available for right this moment. But that would give me the mean versus the median. The median comes from the Latin term media, which means middle value. So this is, we're actually going to look for the exact middle value. Now, if this is 15 values in here, we go from the lowest to the greatest. It's already organized from least to greatest for us, so that is a good thing. So what we're going to do, we're going to go find the middle. So if there's 15 values, that means there is a middle number, and there's 7 values on one side, 7 values on the other side. It's perfectly balanced around that number. Now, the number of values, I don't care what those values are. I just care about what is the actual middle value. So 1, 2, 3, 4, 5, 6, 7. So it's looking like 11 is the median value, right? Because that would give me 7 values on both sides of that. So median, which is usually uses the capital N, M is 7. It is the value of 7. Right? So the median is what we call a resistant value. So if I were to add another value to this data set, let's say I added the value 1,000. Well, if I added the value 1,000 to this data set, wow, is that going to throw the mean off, right? Because the mean, I have to add all those up and then divide by now 16. that would be a really large number all of a sudden, right, where it wasn't earlier. So the mean is not resistant. It got affected strongly by that. But let's think about if I added this one value to it, my median goes from here to right between, because now there'd be 16 values. So you actually have to average the two middle values in order to get that. So the median would change to 12. Okay, so it went from 11 to 12. That's a small shift. That's called resistant. It's not highly affected by such a large extreme value. So know that. We did kind of talk about that last time. All right, I don't want to add that value in there though. That just really throws things off. So that would be, let me get this going here. Oh no, I don't want to do that. Mean versus median, that is the center. Those are the values that we want to use. So the center value, now, which one do we want to use most often? If there is skewness, which this one has, skew right, it's best to use the median because the median is resistant. So the skew is telling me there's some extreme values out there possibly, or that there's some weighting towards this extreme values. The mean is not going to be as good of an indicator of true center as the median will be. Now, if we're talking more symmetric shape, the mean is going to be a good indicator. So the mean would be great for symmetric, median for skewness. So I like reporting median. For the interim, what we're doing right now, report the mean or the median. It really doesn't matter. And go and use a calculator to do that, or use our program stat app. That's a great online, very basic calculator for us. And finally, let's talk about the spread. So shape, outlier, center, spread. So let's talk spread. So spread, we like to use a couple different things. If we're talking about mean, then we want to use the standard deviation. If we're talking about median, it's got a partner called the IQR, or interquartile range. All right, so those are the two things. Standard deviation, again, is a calculation. We like to use S equals, and we give it a little standard deviation calculation. It literally calculates into the average distance of all the values from the mean. So in order to calculate the standard deviation, you have to have calculated the mean first, and then you say, how far is every value from the mean? It's a distance calculation. So that's it. It's got a formula that's not fun to do by hand. So we will always do the standard deviation, and really we'll do these two really all the time in a calculator or in a computer program. We're really going to do the median most of the time in that as well. But let's find IQR. The IQR is Q3 minus Q1, or quartile 3 minus quartile 1. Now let's talk real quick about what is the quartile. Well, the quartile, there's actually 3 quartiles in this thing. One quartile is the first quarter of the data. What is the middle value of the first quarter of the data? The third quartile is what is the middle value of the second half of the data. The second quartile, 2 quarters, is also known as the halfway point, or the median. That is Q2, or also known as the median, right? The middle value. So you never really hear us talk about the Q2, because the Q2 is the median value, so the halfway point. So there you go. All right, but let's talk about quarter one. Quarter one, or quartile 1, is the middle half of the middle of the lower half of the data. So 1, 2, 3, 4, 5, 6, 7 values. So we want the direct center value of that. Well, that's going to be 2. There you go. There is quarter 1 of the data. Quarter 3 is going to be the middle of the upper half of the data. 1, 2, 3, 4, 5, 6, 7. So we are going to get the value 23. So that is Q3. So the interquartile range is literally subtracting Q3 from Q1. So we're talking 21 is that value. So I'm going to write that down real quick. IQR equals 21. Again, 23 minus 2. That's what we get. So I'd report that value. So those are actually pretty easy to do by hand. So feel free to do those by hand, but also calculators will do that for us. So like we can totally let the calculator do that. Again, if you're reporting median, report the IQR. If you're reporting mean, report the standard deviation with it. And then we'll get into logistics after that. So that is a long recap of 1.1 and 1.2. Those are the things I want you to know right now going into what we're doing in 1.3, which is box plots, calculating the actual outlier, not just looking and saying, hey, that one looks way out there, but actually, is it actually an outlier? And then kind of just rolling this thing up a little bit. So these are the things I want you to do next week, is be able to build these graphs, read these graphs, do some calculations, let calculators do it. You give me the assessment, you talk about the socks, those kind of things. All right. We'll see you guys on Tuesday.